Hello, this is Perry Marshall, author of Evolution 2.0, and I'm here with Scott Turner, who's the author of the book Purpose and Desire, which is very interesting, and I think it expresses a lot of latent feelings that a lot of people have about about biology and the life sciences, that purpose in nature has been given short shrift, and and when I read this book, it was like, well, he is merely calling out the fact that the emperor has no clothes, that the reductionist view of things is continuing to not work. And so, Scott, I'm very happy to have you here. Welcome and congratulations on getting this book out there.
Thanks very much, Perry. It's great to be here, and I think there's quite a bit of that you and I have in common with some of your views on Evolution 2.0 and your excuse me, recognition that there really is kind of a middle way in all this has been sorely neglected over the past several decades, actually.
Well, let's start with the first time I ever met you, which was at Cornell at a conference there. You were telling me about termites.
Yes.
And I've seen I've been to Mozambique and seen these huge things. I mean, they're just unbelievable. Like the first time you see them, like you'll do a double take. You're driving in the car, like, what was that? Okay,
Yeah.
so tell us about termites, and eventually it gets to your book. But give us, tell us a little bit about you and your termite stuff.
Yeah, it is a bit of a circuitous path. I was trained as a physiologist, specifically a comparative physiologist. Interested in the ways that different kinds of animals work, and the interest in termites began. I literally just stumbled across them. I was living in South Africa at the time. I had a research appointment at University of Cape Town, which had run out, and at the time, by that time I had acquired a family. My wife Debbie and my oldest daughter Jackie, and I needed I needed a job to be able to hold things together until I could land something more permanent. And so I went up to a small college up near the Botswana border. This was at the time when the homelands were still a political entity in South Africa, and I was up there with time in my hands, and these termite mounds were all over the place, and I started fiddling around with them, and very quickly discovered that the prevailing story for how these things worked was completely wrong. And so that ended up occupying my time for about the next 10 or 15 years trying to figure out what actually was right about them. And along those lines, I started having to think about the way living things are organized, think differently about that. Some insights came in about how these things function as organisms. They act in a coordinated way. Those mounds that they build, for example, are actually lungs for the colony, which is located underground. The termites don't actually live in those mounds. They build this kind of as infrastructure for their colony, and through some quite amazing behaviors, they've engineered this thing into a really well-designed lung that actually works very much the same way, physically and physiologically, the way that our own lungs work, which is
in other words, with the fractal, massive surface area, like much bigger surface area. Is that the idea of what you're saying?
That's pretty much it. That's an important part of it. But the function of our own lungs is actually fairly complicated. It's not just a matter of breathing in and breathing out. There's all kinds of interesting interactions between diffusion and bulk movements of air in our own lungs, for example. And something very, very similar to that happens in these termite colonies. So, in addition to there being some really interesting similarities in morphology, the fractal morphology of the tunnels inside the mound being part of it, but it boils down even to details of function, which again, as I say, has been something that has boggled my mind actually ever since we, actually sorted out how this little amazing system works.
could you give just like a brief idea of what you went into this field and you found that a whole set of assumptions were wrong and you figured out what is really going on? Could that be reduced to a simple explanation at all?
I'll try to. You know, they're at the time there were really two models for how these things worked. One was that that the mound acted kind of like a heart-lung machine, and the colony, which is located underground, generates heat like any organism would, and this supposedly set up a convection cell within the mound that helped exchange heat and oxygen and water vapor and those kinds of things. That's one model. And the other model, and this applies to termite mounds that have chimneys, is that, you know, wind blows and it draws this bulk flow of air through the colony, just like say a wind-driven wind catcher in our own buildings might drive a bulk flow of air through our own houses. And that reliance on bulk flows of air, either driven by the heat of the colony or driven by winds, only encompasses about a third of how this whole thing works. And in our own lungs, for example, when you breathe in and you breathe out, that's a kind of a bulk flow that flows tidally. It flows in and then it flows out. But then at levels deeper than this, you start to get some interesting interactions between the bulk flows that are driven by muscles, in our case, or by winds, or by metabolic heat production in the case of the termite colonies. And beyond that, you start getting into an entirely different mechanism of gas exchange, one that's dominated by so-called diffusion. And the way our own lungs work, it depends upon the interaction between this bulk flows of air and the diffusion gas exchanges. And it's a fairly, you know, complicated and quite sophisticated thing, but the very same kind of thing happens in these termite colonies. So, for example, one of the things that termites do is that they really work hard to prevent any kinds of flows of air within their nest, where they live. And so there's your first point of illogic. You know, why would these termites build these devices to power bulk flows of air through their nests when, you know, the reason for living basically for these termites is to prevent that very thing? And so you know, that's one clue that tells you that, you know, the models for how these things were supposed to work are completely wrong. Basically, they're missing a big part of the physiology. And a lot of the work that we've done is to try to actually measure flows of air. You know, we do fairly standard. We did fairly standard techniques in respiratory physiology, for example, where we applied them to termite mounds and colonies, and the bottom line of that is that the flows of air between the nest and the mound and the atmosphere that everyone was predicting just had to be there actually weren't. In fact, those kinds of patterns of airflow were almost never there. And once we established that, then, you know, the question became, how is it that these termites actually build this thing? And you know, this has led into some into quite a bit of study in what we call the swarm cognition of the termite colony. You know, each termite itself, of course, has a fairly limited range of sensory capabilities. You know, they're blind, they're kind of soft-bodied and these kinds of things, but together they're actually capable of some quite impressive feats of construction. And so it's an interesting question, you know, how is it that the behavior of these individual termites collectively can produce such a remarkable thing? And I think that's sort of what led me into some fairly radical thoughts about, well, just what is it that's driving adaptation here? You know, are these termites, you know, are they little robots that behave according to you know, some kind of program, or are they actually cognitive living things? And you know, when you start appreciating that all of this thing, the adaptation of these termites to some environments where they have no business living, nevertheless they do live there quite successfully. It's all a cognitive phenomenon, and that adaptation is a cognitive process, and that's what enables these creatures to live in a variety of environments where they should not actually be living. And of course, when you start thinking about that, then you start getting into evolutionary adaptation and what's driving that, and that's what led really to the basic theme in Purpose and Desire, which is that cognition is a phenomenon of living systems. It's not found anywhere else in the universe, and it's unique to living systems, and that drives not only the existence of living things in the present, but it drives their evolution as well. And furthermore, because cognition is a universal phenomenon of life, we are cognitive beings. Termites are cognitive beings, but cognition can occur in a variety of different contexts. Swarm cognition in the termites, for example, all the way down to bacterial mats and those kinds of things. And once you get there, then evolution ceases to be something driven by random selection of genes. It actually becomes a cognitively driven process, and that's the basic theme of the book Purpose and Desire.
And so, like, this termite thing was initially just you being extremely curious about something that wasn't even on your radar before. Is that correct?
Yeah. As I said, I literally stumbled into these termites. My principal research work before then was the physiology of heat exchange in different kinds of creatures, mainly because I was interested in temperature regulation, and so we had done some work on blood flow and heat exchange in alligators, and this led to another research question, which is how the circulation of bird embryos within their eggs actually influences and helps affect and control how heat is transferred between the brood patch of the incubating bird and the embryo itself. And that was the work I was doing at University of Cape Town. That work was very much in play there. But as I said, I had to, for family reasons, I had to take a job in kind of an academic exile, and I was there. I had time on my hands, and these things were there. And let's have a look. And that's literally how it happened.
Wow. And when you started doing that, what kind of reactions did you get from people that were more conventionally minded with the old theory?
Well, that was an interesting lesson to me. This old model of how these things work. They were promulgated by a very, very famous and actually a very fine Swiss entomologist named Martin Luscher, and as you may know, the way things work in academia, you have basically lines of descent, and so you have this entire line of descent of academics who were basically disciples of Martin Luscher, and the interesting thing about Martin Luscher's idea was that it was such a beautiful idea. It was carried along literally for decades by the sheer beauty of it. But one of the things that we found out, we tried very carefully to, the evidence that we were gathering showed very clearly right away that Martin Luscher's model for how these termite mounds worked was incorrect. And so we spent a lot of time trying to look into all the different assumptions that went into it. And we found that basically there was nothing about the way the termite mounds worked that corresponded with Martin Luscher's model. To give you an example, this idea that the termite colony generates as heat and generates a circulation of air within the mound, for example, that requires that the nest be warmer than the mound. That's just the way, that makes the air more buoyant and circulates it. But we found just the opposite, actually. The nest is actually almost always cooler than the mound. And so, where's the mechanism there? And so we found that again and again in every assumptions that we tested. And needless to say, this was not received well by this whole, array of disciples of Martin Luther, and so yeah, I got quite a lot of pushback on that. And as I say, it was an interesting lesson, not only in the way that science is organized socially, but also just the sheer power of a beautiful idea, because Luther's idea was truly beautiful, but unfortunately it wasn't correct.
So the Luther guys said that the purpose of the termite mound is X, but the purpose of the termite mound is really Y. Mm-hmm. So what was X and what is Y?
Okay. The X meaning the mechanism, is that what you're asking there?
Well, sure. That's good.
Okay.
Sure.
All right. So I don't know if you if this is general knowledge, but I'm going to be a little bit I'm going to engage in a little bit of stereotyping here, and that is that German science has a very, very distinct way of looking at the world. It has a very strong streak of romanticism in it. For example, this is primarily a result of the influence of Goethe on German science. And they're also very, very strongly mechanistic. The Germans are, no doubt about it, they're excellent engineers, and not all of them,
yes,
obviously.
They are.
This is a little bit of stereotyping, and so this is part of what helped the Luther idea gain such traction. Because think of it, you have this system. It's comprised of mud. It's comprised of termites and all this. And yet it functions as this organism, which is itself kind of an idea that has strong romantic roots in it as well. And so there's that appeal, and then you have this wonderful mechanism where it just runs itself. It's organized so that the heat produced by the colony generates this motion of air. The more excess heat that's produced, the more vigorous the motion is. So it's this kind of a self-regulating system. And as I say, it's just an absolutely beautiful idea. Unfortunately, almost completely wrong. And so now that's the mechanism, and I think that's kind of the roots of it as well. But there was another part of your question that you were curious.
Well, so then the correct understanding in really simplistic terms is, so what's really going on there?
What's really going on is that the termites are actively engaged all the time in adjusting the structure of this mound in order to capture energy that's in the environment to power some kind of a physiological function. And so instead of having this form that emerged from whatever the termites did, that just functioned passively, that is without any agency in there other than the heat being produced by the colony, now you have the active involvement of cognitive agents, and not only cognitive agents but purposeful agents. We know some of the ways in which these termites and termite swarms interact cognitively with soils, with flowing air, and these kinds of things. And if you look at the way these mounds behave, they're not just structures. They're processes. The termites, well, the mound itself it's been likened to a soil fountain, a kind of a slow motion soil fountain, and of course, these things are exposed to the weather, to the rain, and they erode soil all the time. That's going to be breaking down the structure. But at the same time, the termites are continually moving soil up into it and remodeling it so that the form of the mound actually looks the same, even though it's being eroded and you have soil being replaced. But it's actually very dynamic. And if you can see this, if you do time-lapse imagery on these mounds, they change over, from day to day and actually from month to month. And the amount of soil that the termites move to make this happen is immense. I had one poor graduate student there whose task was one year was to figure out just how much soil was being moved up into these mounds. And I scarcely believed the result when I saw it. These animals are moving 250 kilograms of soil. This is dry weight of soil every year up through that mound. That's 1/4 of a ton of soil that's being moved up through these things. And because you have this balance of soil being eroded and soil being replaced, you can get the form looking pretty much the same, but it's actually this very, very dynamic process. And part of that, one of the results of that dynamism of this mound is that it changes its shape subtly and slowly in respect to different kinds of environmental challenges. And in order for this to happen, the termites have to be interacting continually and in a cognitive way with understanding what their environment is, how it's affecting their little world inside the mounds, ways in which you can adjust the structure so that the environment that termites are feeling comes into conformity with some ideal. I hesitate to use that word, but with some kind of notion that's inside the termites' brains, whether individually or collectively, that our environment should be this way. And if it's not that way, we're going to be manipulating this interface between ourselves and the outside environment to make it the way that it should be. And this is where the notion of homeostasis starts to come in as a formative process, as a more general process than we have typically given it credit for in the modern world, and also as a process of adaptation, therefore evolution.
There's two things. We'll get to evolution in just a second, but there's two things that this reminds me of. One of them is it reminds me of a corporation, right?
Yeah.
Or a university, right?
Yeah.
Well, the thing itself is not alive, but it's all these, materials and parts and structures, and there's all these living beings that come in every day and they move all the stuff around.
Yeah.
And the thing really does take on a life of its own. I mean, it's kind of hard not to think of State University of New York, which is where you teach, as anything but this living, morphing organism, not unlike a termite mound. The other thing it reminds me of, there's this really interesting book by Kevin Kelly called What Technology Wants. And it talks about technology the same way that you talk about termite mounds. Like, well, there's just a certain way that airplanes seem to want to be.
Yeah.
Now, of course, most of the time it's not really necessary for him to point out that it's the people making the airplanes a certain way, and it's not the airplanes making themselves a certain way, but that with any particular technology, there are always certain grooves that it will fall into because somebody's trying purposefully and cognitively to get it to do something useful, right?
Yeah.
And so Kevin Kelly's book is all about how technology evolves, right? And you're looking how this inanimate structure called a termite mound takes on this life of its own.
Yeah.
And you're like, hey man, gig is up. Like there's a purposeful process going on here. Yeah. We cannot reduce this to just some thermodynamic, maximizing the heat, or it's not that simple. And so Oh, go ahead,
No,
Scott.
no, 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 that's okay. Finish your thought. I was,
Well,
yeah.
a couple things, and this brings us right into evolution because this connects me to something else. Dennis Noble's got this book, Dance to the Tune of Life, Biological Relativity, that just came out not long ago, and he talks about this idea of biological relativity, which says there is no privileged point of causation, or to put it in maybe more user-friendly terms, there isn't any one place where the cause begins and the effect, cascades down from there. And there isn't any just one single goal of the organism, that there is a whole symphony of things that are going on, and they all kind of work together. And I think it's very significant that both he and you are physiologists. And physiologists are like, well, I study termites, or I study the exchange of air, or I study hearts, which is the case with Dennis. And a heart has a purpose of pumping blood, and we're not going to be shy about that. Like, that is what it does. So I think this brings us right to the doorstep of what your book is ultimately about.
Yeah, and you mentioned that this whole fraught issue of causation and effect, and this has been an ongoing issue in biology for I'll go so far as to say centuries. Just
Yeah.
what is cause and what's effect, and as biology made its transformation in the early 20th century into something that was a strictly mechanistic point of view, that in order to be a real science, biologists had to build the way they think about the world in the ways that real scientists did, physicists and chemists, and this tendency has even been given a name by Ernst Mayr. He calls it physics envy, and kind of a humorous way to think about it. But one of the things that has done is that I think it has deluded us into thinking that we can sort out a cause and effect, and we're deluded into thinking about it because it is a very successful way of thinking about it, but only with certain very, very limited questions and at certain very limited scales. So for example, if you're looking at how energy flows through the photosynthetic complex, for example, you can see a fairly clear chain of cause and effect going on there. But when you look at what's happening actually in the plant itself, then as you mentioned, this whole issue of what's cause and what's effect starts to become very problematic. And this is one of the reasons why I argue that one of the pernicious tendencies in modern biology is that this illusion that we can treat things, we can understand things like cause and effect, has basically alienated the science of biology from the phenomenon of life itself. And it doesn't allow concepts like cognition, like intentionality. We tend to cloak these things behind weasel words like apparent intentionality or apparent design or these kinds of things. And are we doing ourselves any service by taking those things which are arguably the essential aspects of living systems as compared to physical systems? Are we doing ourselves any favors by basically hiding those things behind a cloak of deniability, basically? And so this is one of the things that I'm hoping to correct. And well, I don't know if anyone will pay attention or listen to it, but it's one of the points I'm trying to make in this book, which is that the science of life has worked itself into a little bit of a philosophical pickle because it has ultimately alienated the study of life from life itself. And so that's one of the points that this extends not only to function, but it also extends to evolution as well.
And you're not even suggesting that we shouldn't be trying to figure out cause and effect or anything like that. It's not like anything anti-scientific going on here. You're just saying that the path of cause and effect is so much more complex and interactive that trying to sort of like reduce this to balls rolling down inclined planes or just simple physics is, you know, Carl Woese, rock star biologist,
Yes.
you know, he lamented that this physics envy was making biology into much less of a science than it actually was capable of being.
Yeah, and you know, as I said, you can gain marvelous insights from you know, breaking things down into small parts and, you know, working out the details of you know, where one atom goes compared to the next, you know, and it can lead to some insights that can lead to some very useful things like new treatments or pharmaceuticals or things like this. But ultimately, you know, are you studying life in that case, or are you studying something else? Are you being an engineer, or are you being a scientist? And you know, one of the ways of thinking about life that was actually quite prevalent in the 19th century, and we've tended to lose it, is this very idea that a living system is this collection of agents, these collection of agents with purposefulness and with their own agendas of what they want to be. And I'm using, I know I use scare quotes there, but I'm actually being quite deliberate in my use of the word want. And this idea was something called the many little lives metaphor. A body, for example, acts in a very, very coordinated fashion. The temptation is to think that, well, I can figure out all the programming and things like this that goes into this, but actually an organism is this ongoing process of ongoing negotiation and compromise among the so-called many little lives that composes an organism. And this kind of ongoing interactivity, this ongoing active agency in having a notion of what you should be, and then doing work to make that come into being, you know, that's the essence of intentionality. And that's something that we have really lost in modern biology to a large extent. It's still there, of course, you know, but it tends to occur in fields that, you know, some of the more hardcore biologists regard as a bit squishy, you know, things like psychology and those kinds of things, even merging into the arts and other kinds of expressive disciplines. You know, it's really this focus on mechanism has really driven wedges between so many ways of thinking that should profitably be speaking to one another. And you know, the bridge in my view is to recognize that life is an intentional, purposeful phenomenon. And then the question becomes, you know, how do we fit that into some kind of scientifically credible way of interrogating nature, you know, because what's science after all? Science is basically a means of trying to get nature to tell us what it's all about, you know, without bringing too much of our own prejudices and predilections into it. You know, we're just trying to get nature to tell us what it's about. And if you're ignoring the most important thing about living nature, then you're not going to have a very easy time at that.
So where do you sense that this is headed? Like 10 or 20 years from now, what conversations do you think we could be having that are forbidden right now?
I think we can get away from what I think is a very destructive divide, and you've mentioned this as well. You know, if you look at the public discourse over evolution, for example, you know, it's really, you know, two warring camps that are basically have been chewing over the same bone since the beginning of the 20th century. And you know, if you look at the issues that were at stake in the Scopes trial, for example, And you look at the issues that were at stake in the Dover, Pennsylvania trial, it's the same arguments. And surely we have moved beyond that somehow. Can't we move beyond that somehow? And part of it is you have these radically different philosophical outlooks on life. You have the strict Darwinians that will admit no purposeful agency at all, no matter whether it's from internal to the organism or agency from an external source like the natural, God basically, as the natural theologians would say. And then you have and I don't want to say this is true for all religious people or all Christians, but you have this hardcore notion that cannot admit that there is mechanism, and there is there is a scientific way of thinking about this, and neither side, for a variety of reasons, is working to bridge that gap. And there are constructive areas where those kind of things, those different viewpoints can collaborate. So for example, if you look at how cosmology has evolved, for example, it's gone from the kind of Newtonian idea of the clockwork universe with the creator being just out there somewhere, with the entire universe just being turned into this mechanism. If you look at how cosmology has evolved, it's really gone away from that. And as you get closer to the Big Bang, for example, then physics really has to open up a window for introducing a deity, for example, into our thinking about physics. And obviously there'll be endless debate about what that means. It's ongoing, of course, but that space has opened up as a result
Yes.
of ongoing work in cosmology. And I'm kind of hoping that a similar kind of space will open up by trying to bridge this gap between these two radically opposed camps, if you will. One of the arguments that I make in the book is that there is intelligence and there is design in the living world. If you look at it from any of many viewpoints, you simply cannot deny that life is a purposeful phenomenon, that it has intentionality, that there is design involved. And at this point, you have to ask, well, where does that intelligence come from? And these are radical questions that have to be asked. And on the one side, of course, you have the intelligent design group who have made what, to me, I think is a very effective critique of modern evolutionary theory, even though I don't subscribe to their ultimate conclusion, because what they're suggesting is something like a resurrected natural theology, and natural theology to biology is something akin to Newton's clockwork universe. You have a creator, it's distant, it's set up the mechanisms, and then the whole thing goes. And natural theology had very much that same attitude. It was that you come across the watch on the heath, as William Paley said, and this means there's a designer out there somewhere, something like the Newtonian God. And to me, that's not solving the problem of where the design comes from. It's just pushing the designing agency away from the living things themselves. In other words, it's another way in which the study of life is alienated from the phenomenon of life itself. And of course, the other point of view is that, well, maybe the designing intelligence is something internal to the phenomenon of life itself, and that's very much the approach that I take. But it's trying to build a scientific conversation around these principles of design, acknowledging that these things are real, trying to understand where they come from, trying to do so in a way that nature tells us what's going on, and maybe that will, open up a space for these two warring camps to actually find some common ground, or at least maybe the people who are caught between them,
Yes.
might have some, a way of thinking about it differently.
Well, when I first started discovering things like transposition and symbiogenesis and seeing how cells redesign themselves in real time, I was like, oh my word, how come nobody's told me about this?
Yeah.
Like this should be like this should be on the front page of the New York Times.
Yeah.
And at least 10 years ago, like, well, the intelligent design guys certainly weren't talking about it, and neither were the hardcore Darwinists. And really, I did find that there was this whole middle space where if you weren't married to some extreme ideological thing that for whatever reason you just felt like you had to, that there was this whole area of exploration, which, I can't imagine how you could do good medicine or design good drugs if you didn't acknowledge the ability for the cell to redesign itself or fight cancer.
Yeah, absolutely. The history of medicine, for example, is rife with very scientifically sound, I'm using scare quotes here, therapies that are based upon the best science, and all the experts agree, and these kind of things. It's turned out to be totally wrong, and have probably killed more people than they have saved, and it goes all the way back to this notion of therapeutic bleeding in medieval science, for example. Good heavens, look at the widely accepted theory of how bodies work then, and bleeding actually made some sense in that framework, but it killed most people, and we're running into the same kind of things now, especially with cognitive therapies, and medicinals that can adjust the way the different parts of the brain work. And of course, my favorite example is the radical change in therapy for ulcers, and for example, going from the ulcer is your fault because you're a type A personality and you eat too much fatty foods, to the realization that it's actually a bacterial infection. And all the therapies that supposedly would have worked in the former model actually turn out to be totally counterproductive. That all they do is actually facilitate the bacterial infection that's causing the ulcer. And of course, we're getting into the similar kind of a thing with our knowledge of diseases of the colon, for example, colitis. These are microbial diseases. These come from something that's gone awry in the ongoing relationship and ongoing conversation between, the cells that are descended from our zygote with all the other passengers on this vehicle that is us, which is really not just us, but a whole lot of other cells as well. And so, this notion that there's more to learn, there's a middle way to approach it is absolutely true. But if you look at the history of these things, it's a very, very tough road. If you mentioned symbiogenesis, and of course this brings to mind Lynn Margulis, who was one of the principal advocates for this, and one of the principal intellectual movers for it. And she had an enormously difficult time, trying to make her colleagues see what was just so obvious to her. And of course, Barbara McClintock had ran into similar issues with transposing elements or transposable elements in genes and these kind of things, and they eventually make sense, but it's a very tough road to get there, to get to acceptance. And this I think reflects in an interesting way on the culture of science and how much importance we're willing to give science in quotes, you know, in shaping our own culture, for example. And you know, when you come to the evolution debate, for example, you know, some of the most incredible statements about, you know, how we should teach evolution in schools, you know, come out from this basically very divisive way of thinking about it. You know, it's well, we can't talk about, you know, these kinds of things because they belong over in this other kind of class, and we can't talk about this here in biology because, you know, we're scientists and we don't admit these other things. And it leads to ultimately to, I think, a very destructive way of teaching students about evolution, about a lot of things. You know, Lynn Margulis called it intellectual apartheid. You know, that what you do is you take disciplines and you build huge walls between them so that, you know, you can have a safe space for one discipline and then a safe space for another, but they don't talk to one another. You know, and again, you know, this comes from this ongoing divide that's decades now between, you know, different ways of looking at the world. And,
Yes.
you know, is there some way that you can find a common language so that everyone can talk to one another? You know, I don't know. I hope so. That's the whole premise of my book, after all.
My observation is that it's almost always outsiders who show up and go, who put this wall here? And who put this wall here, right? I mean, you're basically, you're critiquing evolutionary theory from the perspective of a physiologist who studies termites, who is most emphatically not an evolutionary biologist. In fact, I think it was Ray Noble said, evolution is too important to leave to the evolutionary biologists. And what I think is really ironic is evolutionary biology has been one of the most resistant fields to evolving of any field. And I've consulted in 300 industries. I mean, I've never seen anything quite like it. But then you go just outside. You go just outside those walls, and you find people doing an enormous, like Dennis Noble gave a keynote a couple months ago to, I don't know how many physiologists. He's the president of the Physiology Association, and they're all like, preach it, brother. We love this new version of evolution. And of course, it's very friendly. Like, it's not trying to alienate anybody. It's like, hey, life is doing what life is doing. Well, last question before we go. Are you finding any difference between the conversations among biologists that are allowed to happen in public being different than the ones you have in private? When you talk about your book, and if you take away the political correctness police, is there a difference in what people are willing to embrace and talk about?
I think so. I think it's very hopeful, and actually, I think it's a very exciting time to be a biologist right now, because I think we're in the midst of a transition toward realism, realism about what life is now, and I just want to give you an anecdote, and it's related to my second book. I'm not trying to flog my second book here, but
please flog it. It's fine.
Okay, I'll flog it. It was called The Tinkerer's Accomplice, and it was explicitly about the problem of biological design. Again, approached from my perspective as a physiologist, and that had the unfortunate fate of coming out just at about the time or in the aftermath of the Dover trial, and the subtitle of the book was How Design Emerges from Life Itself, and just that word in there, caused all kinds of interesting difficulties. We had people who refused to review the book. They were accusing me of being a shill for the Discovery Institute. There were some rather strange things that went on. For example, there was one instance where I know I left behind some very angry faculty members at a university where I gave a seminar on this thing because, you know, we can't have intelligent design, you know, at our seminar program. And so there's a lot of that stuff going on, and it was an example of the way that, you know, conversations don't happen. But the people that I've run the book by, colleagues who, I have to admit, I was a little bit nervous about putting it in front of them because I thought that I might get the same reaction to this book, but it's been very, very positive and very open. And in fact, some of the more strident things that have been expressed to me about purpose and desire haven't come from my professional colleagues. They've come, as usual, from, you know, internet trolls that,
Yeah.
you know, put on comments, and they obviously have not read the book and haven't given much thought, or, you know, are interested in, you know, extending outside the thought bubble. But, you know, so far it's been very, very positive. And so maybe things are changing, you know. It's helped along, I think, by the fact that there's a growing realization amongst evolutionary biologists that our standard model for Darwinian evolution, namely gene selectionism, doesn't really help explain much, and there's this vast territory of things that maybe can be explained by bringing in these formerly squishy ideas like intentionality and purposefulness, you know, things that had not been allowed to be part of the discourse for many, many years. So I'm hopeful. I'm hoping it's going to be well received. Mainly, I want to start conversations.
Well, I think that's the whole thing, and you know, I think some of this, you know, clinging to the reductionist mindset, I think there's an element of almost like worshiping at the altar of exact answers. I mean, I understand physics envy. Like, I'm an electrical engineer. I understand physics really well, and it's incredibly precise. And, you know, it's not anywhere near as easy to like understand my wife. You know, right?
Don't tell your wife.
Or well, she knows it. She'll be the first to tell you, right?
Right, yeah.
Or you know, or boy, you know, how do I get the cats to quit peeing every time somebody leaves a towel in the bathroom or something? Like, you know, these are a lot harder problems to solve than physics, and like biology it's just harder. It's like and another comment about like it's the trolls that are causing the problem. It's not really professionals. I found when I got ready to launch my evolution prize, I had to go get some judges, and what I found was, and I found this in general, that the higher you go in the accomplishment level and the more open people are to different ways of twisting the Rubik's Cube. My observation is that if you go to a junior college someplace where the professors are marginal, you're likely to get really militant kind of Richard Dawkins-like reactions to stuff. But, you know, I've got people on my team like Dennis Noble and George Church and so on. And like, they're not afraid of controversy. They're not afraid of completely different ways. They're inviting, you know, when Dennis did his meeting at the Royal Society last year, I mean, he brought in the British Academy, and he had all of these people from anthropology and sociology, and you know, it was like, hey, we need as many views of this thing as we could possibly get. And I just think I found that there is definitely a place now. I don't know if it even existed 5 years ago, but it definitely exists now where you can have some wonderful conversations.
Yeah, I think it is changing. I've noticed a difference in climate from the time the Tinker's Accomplice was published to now. In evolutionary biology, for example, a lot of these really interesting conversations are are happening around the new theory of niche construction, you know, which even though the major proponents of niche construction don't want to admit it, it actually opens the door for bringing you know, purposeful agency back into the evolutionary process. And I've been invited to a few of those conferences, and I've also been invited to a few intelligent design conferences, just because I want to get to know these guys and figure out how they think and things like this. And there are interesting conversations emerging, and I think a more open attitude. And now it's just a matter of, you know, continuing to explore, continuing to ask, and as you say, you know, have conversations where conversations weren't possible before. And if I had to point to one hope that I have for the book, is that we'll start opening up those conversations.
Well, I want to encourage everybody, pick up a copy of Purpose and Desire at your local bookstore or Amazon by J. Scott Turner. Lots of interesting little stories and angles, and his it clearly took you a long time to write this. This was not some 12-month project, obviously.
No, I started it on my last sabbatical, actually, in Cambridge in 2010, and it's gone through about 5 different complete rewrites since then. You know, so it was very much a long-term project, and yes, I'm really glad it's published now.
Yeah, well, skillfully written, very intriguing. Well, thanks for doing what you're doing. Congratulations on making termites interesting to regular folks like us, and thanks for your time today.
Thanks so much, Perry. It was a delightful conversation.